Hey guys, welcome to our next installment of solving systems of equations using substitution. Today I am representing the Jackson basketball team. Please make sure that you go out and support your Jackson team and root them on this week. Alright, some very important concepts that we're going to be looking at today is what is substitution. Substitution is when you replace something with an equal value. We're going to be using 3 steps today when solving these systems of equation. The first one is that you need to make sure that at least one of your equations is solved for either x or for y. It doesn't matter which variable you solve for, just as long as there's one that says x equals or y equals. Then you're going to take that x value or y value and substitute into the other equation in replacing that variable. Once you do that, you will end up having only one variable and you can combine them and solve for it just like a normal equation. That will give you either that x value or that y value. Once you know what x or y is, then you can plug it back into either of the equations and find the other variable. Now today we're going to be writing our solutions in the form of an ordered pair, your x value and then your y value. And I'm going to also show you how to check your equations. When you're checking, you need to make sure that both equations come up with true statements. If they both don't check, then it is not a solution and you'll need to go back and check your work. Alright, let's go ahead and get started with example 1 today. Alright, so here's example 1. Basically, we have the system where y is equal to 2x plus 1 and 3x plus y is equal to negative 9. In our step 1, we needed to make sure that at least one of our equations was solved for one of the variables. In this example, y is already solved in one of our variables. So we're going to take this y value and substitute it into our other equation in place of y. So I'm going to box that in and draw my arrow to the y, because instead of putting our y, we're going to replace it with that value that is equal to y. So we have 3x plus y, which is that 2x plus 1, equal to negative 9. When I do that, I don't have 2 different variables in that equation anymore. I only have one variable x. And I can combine them and make 5x plus 1 is equal to negative 9. And then you can solve it just like you would a normal equation. We're going to subtract that 1 on both sides, leaving us with 5x equals negative 10. When you divide by 5, you are left with x equals negative 2. Now that you know what x equals, you can substitute that back into either equation and find out what y is. I chose this first equation because it seems like it's a little bit easier and it will only take me one step to plug it in and solve. I wouldn't have to move anything over and solve for y, so it's nice and already kind of solved for me. 2 times that x value, negative 2, plus 1. 2x plus 1. So I replace my x with my x value. 2 times negative 2 is negative 4. Negative 4 plus 1 is a negative 3. So now I have my x value and my y value, and I can write my solution in an ordered pair. Negative 2, negative 3. We still need to go back and check that to make sure that we didn't make a mistake somewhere. So when I do that, I have to plug in back into both original equations. This one is hard to read, so I'll go ahead and darken that up. Alright, so when I did that, I plugged in my y value for y and my x value for x. 2 times negative 2 plus 1. 2 times negative 2 is negative 4, plus 1 is negative 3. Yes, negative 3 is equal to negative 3. Over here, we have 3 times x plus y is equal to negative 9. Plug in my x value for x and my y value for y. 3 times negative 2 is negative 6. Negative 6 and a negative 3 make negative 9. Yes, negative 9 does equal negative 9. So that is our correct solution, and we know we can go on to the next example. In this example, we're going to go ahead and do it together. Remember what step 1 was. We had to make sure at least one of our equations was solved for one of our variables. In this example, neither equation is solved for either of the variables. So we get to choose either one to solve for. I like to do less work if possible. So look at this one. If I move this 2y over, then it will say x equals. So I only have to move one thing and I've already got it solved for x. So that's what I'm going to do. So I'm going to subtract 2y on both sides. And that leaves me with the equation x equals negative 2y plus 6. And it does not matter which order you write that in. You could have said 6 minus 2y or negative 2y plus 6. It does not matter. Because basically x is equal to that whole value. So now that we know what x is, I can plug it back into the other equation and find out what y is. Since I've already used this one, I can't plug it back into itself. So I'm going to plug it back into the other equation instead of x. So 3x minus 4y equals 28. And what did we say x was? We said x was negative 2y plus 6. Let's go ahead and use our method of solving equations to solve this example. If your problem has parentheses, use distribution to get them out of here. 3 times negative 2y is negative 6y. 3 times positive 6 is an 18. Minus 4y equals 28. Let's go ahead and combine like terms. I see that these are y values and these are y values. Negative 6 minus 4 makes negative 10 of those y's. And I bring everything else down. Just solving it like normal. So I would, of course, minus 18 from both sides to cancel those 18's out, and I get negative 10y equals 10. Divide both sides by that negative 10, and you can see clearly that y is equal to negative 1. Remember, once I know what y is, I can plug it back into either of those original equations. I always go back to the original equation instead of the one that we solved, because what if I accidentally made a mistake from here to there? So I like to go back to my original equation when I am checking them and when I am plugging them back in. So let's go ahead and take that y value and I'm going to plug it back in. This one looks like it's less work, so let's go ahead and use that one. X plus 2y equals 6. What is y? Y is equal to negative 1. So I'm going to plug that in and now I can solve. X plus, 2 times negative 1 is a negative 2 equals 6. Add 2 to both sides. X equals 8. Remember, when you're writing your solution, it needs to be in an ordered pair form. So my x value always comes first in the alphabet, and my x value always comes first in the ordered pair. Let's go ahead and check it. Remember, when you're checking, you always want to plug it back into your original equations. My x value for x, and my y value for y. In this case, the x value is 8, and the y value is negative 1. 3 times 8 is 24. Negative 4 times a negative 1 is a positive 4. 24 plus 4 is 28. Since 28 does equal 28, we know that one's a check. Am I done? No. I got to go back and check the other equation now. So let's plug it back into here. X plus 2y equals 6. Remember, we said that x was 8 and y was negative 1. 8, 2 times negative 1 is a negative 2. 8 minus 2 is 6. Yes, 6 is equal to 6, so that one checks as well. So it is a solution. Alright, let's go ahead and finish up with example 3, and it's a word problem. If you turn to the very front of your notes, you'll see this word problem written at the beginning. They asked us this in our intro. It said, 2 movies were released at the same time. Movie A earned $31 million in its opening week, but fell to $15 million the following week. Movie B opened at $21 million, but fell to $11 million the following week. If the earnings continue to decrease at the same rate, when will they earn the same amount? First of all, we always want to label our variables. So I chose X being my number of weeks and Y being my earnings, because those are the two things that I'm comparing. Then I went ahead and color-coded it. Movie A. We said that it was 31. It ended up being 15 million. So when you subtract them, it is a loss of 16 million per week. So our equation would be $31 is our starting value minus 16 million per week times X. Movie B was 21 million and went down to 11 million. When you subtract them, that is a loss of 10 million per week. So we have our equation 21 minus 10 per week. So y equals 21 minus 10x. Solving our systems, we know that we have these two equations. 31 minus 16x for movie A and 21 minus 10x for movie B. Remember, as long as one of them is solved for one of the variables, you're ready to go. If not, you would have to solve for one of those variables. In this case, they're both solved for y. Does it matter which one I substitute in? Absolutely not. I chose the first one because that's what's there first. So I highlighted it and plugged it in place of that y value. I substituted it in. So instead of my y, I'm going to plug in something equal to it, which is 31 minus 16x. So my y still equals 21 minus 10x. Now I can solve it like I would a normal equation. I'm going to add 16x to both sides to cancel these out. And I'm left with 31 equals 21 plus 6x. When I do that, I'm going to subtract 21 on both sides to get rid of that, and I'm left with 6x equals 10. Divide by 6 on both sides, and you get 1 2/3 weeks is when they will be the same. If you want to know how much money they will have earned each, then you can plug that x value back in to see what it would be for y, our earnings. When I do that, I get $4 1/3 million for each movie after 1 2/3 week. Please go ahead and try the next problems, and I've included scribbled answers for you to check. I'll be walking around to help you.